Okay, so here we have question 8. Thomas determines the area A, so this is area up here on the y-axis, this is area here, in square meters of a rectangular farm by using the formula A equals x times 60 minus x, where x represents the length of the farm in meters. Okay, so here's the length of the farm in meters. Thomas draws a graph in the shape of a parabola, so this is a parabola, representing this formula here. Now, the question is, what is the maximum area in square meters of the farm? So the maximum area is obviously going to be the highest point on the parabola, which is up here. And what we know about parabolas is that they are symmetrical. So that highest point up there, everything on the left-hand side of that point is going to be the same as everything on the right-hand side, okay? So this distance here is the same as this distance here. And the highest point is going to be the point that is directly in the middle of 0 and 60. Sorry, 60 is where it cuts. So 60 is actually here. So what's the maximum area? Well, first of all, we're going to need to use the equation. This is our equation. We're trying to find the area at this point, but we're going to need x. We're going to need an x value for this. Otherwise, we're going to have two unknowns and it's not going to work. So we need an x value. What is the x value here where the highest point is? If it's exactly halfway between 0 and 60, then the x value is going to be 30. Okay, so if we put 30 into our equation, then it's going to give us a. So it's going to tell us what that value of a is up there. So let's put 30 into the equation and see what happens. So everywhere there's an x, we put 30. We're left with a equals 30 times 30. So we're left with a equals 900, and it's meters squared. So that means that up here, this point on the graph has an x value of 30 and a y value of 900. Okay, so here is 900, and the highest point is clearly 900. So the biggest area, the greatest area, the maximum area is 900. So 8 is B. Question 9. The hiring charge, C, for a bobcat is determined by the formula C equals 1,385 times D plus 850. So this is a cost. Already, I'm going to assume that this here is our set value. This is our fixed cost. So regardless of how long you're hiring the bobcat for, it's going to start off costing $850 just to hire it. And then over here, this isn't fixed. It's affected by D. So D is probably going to be some sort of time, some measurement of time, okay? And it's going to go up in price depending on how long you're hiring it for. And let's keep reading. All right, where D is the number of days. Yep, so it's time. So if you hire it for more days, it's going to cost more because this number is going to go up here and we're multiplying by a larger number. D is the number of days the bobcat is hired, irrespective of the number of hours the bobcat is used on any day. Okay, so that means that regardless of whether you hire the bobcat for half a day or even for just 2 hours, it doesn't matter. You're still going to get charged for the full day. So this can only go up in days. There can't be any decimal or fractional values here for D, all right? So what is the total cost of hiring a bobcat for 17 days and 7 hours? All right, so we just said we can't do a fraction. We can't do 17 days, 7 hours. We have to do either 17 days or 18 days. Unlucky. If you use the bobcat for 7 hours on this day, you still have to pay the full price. So if you need it for 17 days, 7 hours, you actually need to hire it for 18 days. You need to hire it for that full extra day. So our number of days is going to be 18 days. So D is 18. Now let's find out the cost. All we need to do is substitute D equals 18 into our original formula up here. So C equals 1,385 times 18 instead of D plus 850. All right, so the cost, we just need to evaluate everything over here. So we can use a calculator for that. 1,385 times 18 plus that fixed cost of 850. Okay, so our answer is 25,780. So be careful, pay attention to the question here, all right? Don't worry about this extra 7 hours if it says that you have to pay for the whole day anyway. So it says, irrespective of the hours, the Bobcat is hired for the number of days. Okay, so 25,780 is D. So the correct answer is D. All right, and the last question is question 15, and that's a network diagram. So this one might take a little while. It's the last question, so they're going to make you work for it. Okay, so question 15. First of all, we need to fill out all of our earliest starting times, and then we need to work backwards and fill out all of our latest starting times. And you can see straight away from the question that they've given you space to do that. So that's a pretty good place to start. Okay, so we're starting with 0. We always start with 0, and we fill out the left-hand side first, which is the earliest starting time. Okay, now we go on. If we want to go up here to this next one, there's only one pathway that leads there, so it's just going to be 0 plus 2. It has to be. There's no other pathways. This one here, again, there's only one pathway leading here, so it's 0 plus 1. And again, only one pathway that leads here, so 0 plus 5. All right, next one here, there's only one pathway again, so it has to be 5 plus 2. So that's nice and easy. This one up here, there's 3 different edges leading to it. So there's 3 different pathways. So we'll leave that for now until we know all 3, because at the moment we only know these 2. We need this one first. So up here, how many pathways lead to this one? Only this one here. So that's nice and easy. 2 plus 3, 5. All right, now we've got all 3 pathways that lead to this one, so we can choose which pathway we're going to choose. Well, when we're doing the earliest starting time and we're moving from the start to the finish, we always select the pathway that takes the longest amount of time, okay? So we have to factor that pathway in. So in this case, we've got 5 plus 2, which will give us 7. Here we've got 1 plus 4, which gives us 5. So far 7 is the longest pathway. And down here we've got 7 plus 1, which is 8. So this is actually the greatest value. So this is the one that we're going to put in, 8. Now we're moving on to our next one. Okay, so how many pathways lead here? We've got this one and this one. So we've got 2 possible edges leading towards this vertice. So this option up here is 5 plus 6, which gives us 11. And this option here is 8 plus 7, which gives us 15. So 15 is the greater value. So 15 is the one that we'll use. And then there's only one edge here that leads to the last point. So it's 15 plus 2, it has to be. Okay, so now we've got our earliest starting time, and our latest starting time is also going to be 17 now. And we're going to work backwards to fill in the right-hand side of the boxes. Okay, so there's only one arrow that leads back here, so it has to be 17 minus 2, so it's 15. Now, if we were to do this one, well, there's actually 2 arrows that lead back here. If we follow these backwards arrows, we follow these arrows backwards, there's 2 that leads here. So we need to know this one first before we can choose which edge we're going to follow the pathway along. So we will leave that one for now because we don't have this. Can we fill in this one? How many edges lead back here? Only 1, okay? Because these edges are going forward. We need the one that goes back along the arrow backwards. So this one is 15 minus 7. So that leaves us with 8. So you can see that this is the critical path so far, because these are the same, these are the same, these are the same. So critical path is going to come along here. Okay, now we can do this one because we've got two options. We can do 15 minus 6, which gives us 9, or we can do 8 minus 2, which gives us 6. And now when we're working backwards, we don't take the largest value anymore. We have to take the smallest value, okay? The shortest time. So 8 minus 2 is the shortest, so it has to be 6 up here. We can go here and do this one because there's only one path leading back, so it's just 6 minus 3. What else can we do? We can't do this one yet because there's all these different pathways leading back, so we need to know these. We can do this one because there's only one path that leads backwards here. So it's 8 minus 4 is 4. We can do this one because there's only one path that leads back here. So it's 8 minus 1 is 7. So you can see this is the critical path because the earliest starting time and the latest starting time are the same. So that leaves it with no time to spare. And then this one again, there's only one path leading back here. So it's 7 minus 2. So we're still on the critical path. But we have to be, we've got no choice. There's nowhere else to go. And then we can decide this one. We've got 3 different options and we have to choose the smallest value. So 3 minus 2 is 1. 4 minus 1 is 3, so it's not that. 5 minus 5 is 0, so that's the smallest value clearly. So the critical pathway is from here to here, up here, and then out like that. So that's the critical pathway. Now, what's the question actually asking us? So it says if activity G is delayed by 5 hours. So where's activity G? So activity G is up here. It's got an earliest starting time of 5 hours and it's got a latest starting time of 6 hours. So that means that this activity can start at 5 hours, but it can also be delayed by 1 hour and start at 6 hours. So that means it's got a float time of 6 minus 5, or 1 hour. It's got a float time of 1 hour. So that means that we can actually delay this activity by 1 hour and it's not going to affect the total time for this process to be completed. So the question asks us to delay it by 5 hours. So for the first hour, it's not going to affect it. But for the remaining 4 hours, that's going to delay the whole thing by 4 hours, okay? So the question says we're going to delay it by 5. How much is that going to delay the whole thing by? How much is that going to delay K by over here? Sorry, it says how much will K be delayed by, and K is right at the end over here. How much will it delay the critical path by? Well, it doesn't matter about that first hour because we've got a float time of 1 hour. But the remaining 4 hours, it will delay this critical path by 4 hours. So your answer is basically going to be the amount they asked you to delay it by minus the float time, which is 1, okay? So it delays the process by 4 hours. So it delays K by 4 hours.